everyone, and welcome to the Industrial Energy Transformation Fund briefing event. My name is Jenny McDonald from KTN, and I'm hosting today's event on behalf of BEIS and Innovate UK, ably assisted by my colleagues Aileen Woodley and Jonathan Abra. So next slide, please, Aileen. So before we get started on today's presentations, just to run through some housekeeping points. Now, you guys are all over there on YouTube, so you can't actually say anything during the event. So if you do want to ask a question during the event, then please type your questions into the chat box on YouTube. My colleague Jonathan Abra is in YouTube land with you, and he will make sure that your questions get passed over to BEIS and Innovate UK when we get to the Q&A session. Make sure you say who you are as well, your name, your organisation, and the particular competition that the question relates to, because that will just help us to give you the right information. Now, as far as I'm concerned, there's no substitute for a live event in terms of networking, but we're all getting very good after nearly 18 months of COVID. We're getting very good at doing this virtually. So please do introduce yourselves on YouTube. There's over 450 people registered for today's event. So there's bound to be somebody there with you online that you might be able to partner with or work with in the future on some projects. Today's event is being recorded, so if you have registered for today's event, and you will be sent a link with the recording and also the presentations that you're going to see today after the event, and you can watch again and share with colleagues. We also recorded the briefing event that we did in March, which had a little bit more detail on how to apply, and we can send that link with this as well. And finally, once today's event is over, we have organised some one-to-one discussions. So these are confidential 10-minute discussions that you can have with either BEIS, Innovate UK or myself via the Meeting Mojo platforms. This is our dedicated Ietf networking platform, and we'll be doing these 10-minute meetings between 1:30 and 3 o'clock today. So if you haven't already joined the Ietf networking platform and you would like to have a 10-minute discussion with BEIS, Innovate UK or myself, then you can register at the link there, and Jonathan's going to put that into the YouTube chat box for you too. Next slide. So today's agenda, well, obviously this is the welcome and housekeeping. I'm then going to hand over to BEIS, who are going to talk to you a little bit about the policy context for this, why this is important to them and why they're providing the funding now to help you to decarbonise. We'll then move on to a presentation from Innovate UK that will cover the scope of the two competitions and a little bit about eligibility as well. And then based on the questions that we've had in phase 1 last year and the spring window so far today, this year, we've got some of the more frequently asked questions that we thought we would run through because that would hopefully be useful to you too. You'll then get your first opportunity to ask any questions that you have. Now, we're not taking questions on your specific project ideas, because we're going to save that for the one-to-one sessions after the event. But if you've got any questions more generally about the scope or eligibility or how to apply, then please do type them into the YouTube chat box. Don't wait for 10:50 when we actually have the Q&A session. Type them in as soon as you think of them, so that Jonathan can pass them over to us and we can start preparing our answers for you. We'll then have a short comfort break, 10 minutes to stretch legs, make a cup of tea, and before we then move on to our case studies. And I'm very pleased to say that we have 4 of our funded projects from phase 1 are going to be sharing what they plan to do, funded by the Ietf. There's a range of different manufacturing sectors that have been funded, and also a range of technologies that they will be planning or deploying on their sites. So hopefully that will give you some ideas of what you can do on your sites too. After that, there's a short Q&A, so you can ask them questions about their projects, or again, you can ask us questions about the scope and overview. And then finally, I'll wrap up with a presentation just explaining some of the support that's available to you to help you with your application. and to find the information that you might need. And then we'll wrap up at 12:40, and that's the end of the event on YouTube. We'll then have a short lunch break before we move on to the Meeting Mojo platform if you've booked a one-to-one meeting with BEIS, Innovate UK or myself. So hopefully all of that will be of use to you today, and you will find the presentations interesting. And we'll kick off now with our first presentation from Paro Konar. Paro is the Director for Industrial Energy at BEIS, and she's going to, as I say, set the scene with a little bit of policy and an explanation of why this funding is available to you now. So Paro, over to you.
Thanks, Jenny. Can you hear me? You said in your introductions really nicely that we're all very used to this right now working on Zoom, but I've had several mishaps in terms of making sure that I'm mute or unmute when I need to be. Can I please check that you can hear me?
Yes, you're coming through loud and clear.
Excellent. Okay. Hello, everyone. Good to meet you all. I'm just going to quickly introduce myself before I start presenting through my slides. My name is Paro Konar. I job share with Stephanie Murphy, and together we're the directors for industrial energy. Our job is to look to decarbonise the industrial sector in the UK. And we do that with various policies and funds to support us. We're going to be talking about one such fund today, the Industrial Energy Transformation Fund, but I thought it would be a good idea to also sort of run through some of the other stuff that we do in the Directorate and wider across government to support industrial decarbonisation. If you could move on to the next slide, please. Thank you. So that's the challenge set out right in front of you. The challenge is quite large. Well, the UK's industrial sector is quite a large sector, and it contributes to around, if you look at the different types of statistics, they're often quite different, ranging from what exactly they're looking at. But if we consider businesses as well as industry, a quarter of UK's emissions come from this sector. And by 2050, the sector needs to be nearly fully decarbonised from 2018 levels. So there's a big job to be done. How are we going to do it? So we published the Industrial Decarbonisation Strategy in March this year. And in this strategy, we sort of put out several pathways in which we're going to be looking to be showing model scenarios of how the UK could decarbonise its industrial sectors. And do encourage you to take a look at the Industrial Decarbonisation Strategy if you haven't had a look yet. But within the strategy, we're looking to decarbonise about 2/3 of our industrial emissions by 2035. And like I said, by 2050, we need to have nearly fully decarbonised in the industrial sector. If you could move on to the next slide, please. Thank you. So there's a lot to be done for us to be able to decarbonise the industrial sector, and I think a lot of funding and a lot of policies need to support that. So we're going to be talking about the Ietf today in a lot of depth. I'm not going to do that in this slide, but I wanted to introduce you to a few other funds that might be available for you. There's the Transforming Foundation Industries Programme, which is worth about 66 million. There's the Carbon Capture Usage and Storage Fund, and that fund is worth about £1 billion up to 2024. There is a fund for low carbon hydrogen production, which is £240 million, which is available up to 2024 as well. And then there is the wider Energy Innovation Programme. As you'll see in the map, a lot of our emissions across the UK is clustered, so primarily clustered in 6 industrial clusters. 50% of our industrial emissions actually come from these clusters. So there's a fund which is run actually by Innovate UK worth about £170 million, which is looking to seek ways in which we can reduce industrial emissions in these 6 clusters. There's a lot of other policies that we are looking to support industrial decarbonisation with. We are committed to carbon pricing. The UK emissions trading scheme has been launched in the UK from the 1st of Jan 2021, and we recently launched the auctions on the 19th of May, and we've also launched the futures markets. So there's a market-based way of reducing industrial emissions. We've also published our response on the carbon capture business models alongside the industrial decarbonisation strategy, and that sort of gives you a long-term way in which you can reduce both. You can sort of think about how the capex and opex costs of large industrial decarbonisation schemes using carbon capture and storage can be funded. If we move on to the next slide, please. Thank you. So, like I said, today we're here to talk about the Industrial Energy Transformation Fund. And this fund was set up really recognising that energy costs are a significant proportion of costs for running an industrial project in the UK. And this fund is actually designed to support you with your high energy costs, to cut bills, but also to support the transition to reduce your carbon emissions. The Ietf, as you know, will provide funding for capital investments in energy efficiency and deep decarbonisation projects. And our aim is to reduce energy costs and emissions for industry and to bring down the costs of these deep decarbonisation technologies. If you move on to the next slide, please. Thank you. So you'll be hearing presentations from a number of colleagues who are listed on this slide. So I won't go into too much detail here. The Ietf is a competitive fund. Our bids will be assessed and compared. And we've got colleagues here from both Innovate UK as well as KTN who can help you with questions through your applications. And it was really good to hear from Jenny that you're going to be able to sort of have individual one-to-one sessions to deal with your specific project questions, and we look forward to helping you with that. So if you could move on to the next slide, please. Thank you. As you know, we had our first phase one, which was launched last year in summer 2020. It was extremely successful. We had 39 applications for this fund, and we have agreed funding totaling £31 million. The first tranche of winners was announced on the 24th of May, and in recognising the amount of interest for this fund and the fact that this fund is actually really sort of supporting the decarbonisation aims and ambitions for government as well as for industry, we have decided we launched a second part of phase one this year. This, as you're aware, has been open from 8th of March, and the window closes on the 14th of July, and there is £40 million worth of funding available to you. As the first window, which was launched last year, we are primarily focusing on energy efficiency projects. But if you have, but we are also offering funding for studies for energy efficiency as well as for deep decarbonisation projects. If you could move on to the next slide, please. Thank you. So this slide just gives you a bit more detail around the competition winners of summer 2020. It was very, very successful, and a large number of applicants came in. We went through a process by which we assessed those applications and we announced the competition winners. The first tranche of those were announced on the 24th of May. There was 14 winners who were announced, and and we talked about funding that we awarded approximately £16.5 million. And we are waiting for those contracts to be signed and delivered. But a large number of sectors that the funding is going to be awarded to across geographical regions in the UK, which supports our levelling up agenda, and a large variation of types of industry that funding has been awarded to. So if we move on to the next slide, please. So there's a broad, Ietf has a huge remit in terms of what we can fund, and there's a lot of detail around the eligibility rules. So all eligibility rules across both of the funding that we announced last year as well as this year is online. So I do encourage you to go and take a look at those rules. But for specific questions about eligibility and for any proposals, please use Innovate UK's eligibility screening service. Or please do attend one of our stakeholder clinics. As the slide says, we've really taken a technology neutral approach, but our guidance will give you a bit more detail around what kinds of projects is eligible for this funding. If you move on to the next slide, please. Thank you. So really, we're here to support you. This event has been run to do that. We're here to support you, to encourage you to apply and to answer your questions. So please do put in your questions today, and we look forward to helping you bring forward high quality proposals so that we can provide our funding to you. If you have any doubts about eligibility or indeed about your project, and if you'd like to discuss your project in depth, please do get in touch with us, and we can work with you to understand whether the proposal fits the scope of the competition. We can work with you to make sure that we can put you on the right track if it doesn't. We do advise that if you could get in touch with the applicant's support services as early as possible. Things do tend to get busy quite towards the end of as the closing date approaches. So the earlier you are with your questions, the more time we can offer you to do that. So all of the details and where you can get in touch with us are on this slide. So please do strongly encourage you to come forward with your questions, and so that we can support you in putting good quality applications forward. If you move on to the last slide. So thank you. Yeah, that's all I wanted to present to you today. I'm afraid I have to leave at the end of this presentation, but my colleagues here from BEIS, particularly the head of the Ietf team, Catherine Barber, as well as a number of members from her team are here today. So we are available to answer any of your questions, and can deal with any suggestions or any further queries that you might have. I'm going to hand back over to Jenny, who can take us forward from there. Thank you.
Thank you very much, Paro. That was great. So as Paro said, if you've got any questions about what you've just seen, if you want to share any comments with BEIS, and then please pop those into the chat box on YouTube, and we will do our best to respond to those for you. Our next presentation now is from Julia Schumacher from Innovate UK. Julia is the innovation lead for the Industrial Energy Transformation Fund, and she's going to talk to you about the scope of the two competitions and as I say, a little bit about the rules and the eligibility of applying. So over to you, Julia.
Thank you very much, Jenny, and thank you, Paro. So yes, hello everybody. I'm here now to talk through with you a little bit more about Ietf, going into a little bit more detail about the competition and also the scope and the eligibility. So if you've got any project ideas, hopefully this will be able to give you an indication if they're suitable for Ietf. So just to recap a little bit about what Paro mentioned in terms of Ietf. So overall, it's a £315 million fund to support high energy businesses transition to a low carbon future. So £289 million of that is allocated for businesses in England, Wales and Northern Ireland, and £26 million is allocated for Scotland. So Ietf is split over 2 phases with the interim spring round that we're in now. So as Paro mentioned, phase one was £30 million, which was allocated to projects. We're going to be hearing about some of those successful projects later. The spring round, which we're in now, is 40 million, and then phase two, which will be for the remaining budget, will be announced later in the year. Okay, so there are two strands to Ietf, deployment and studies, and I'm going to run through both of these with you, starting first with the deployment strand. So the deployment strand enables companies to deploy mature energy efficient technologies that improve the energy efficiency and reduce energy demand of an industrial process. So the minimum grant funding that you can apply for is £100,000 per project, with a maximum grant of £14 million. In terms of eligible costs, this funding can go towards costs that are associated with the higher level of energy efficiency of your project. And I'm going to touch on eligible costs in a little bit more detail later. So also the second strand, which is the studies strand, and this can either be covering feasibility or engineering studies. So both feasibility and engineering studies enable companies to determine the benefits of deploying a mature energy efficient technology or a deep decarbonisation. So the minimum eligible project cost for a feasibility studies is £30,000 per project, and these projects can last up to 12 months. And the minimum eligible project cost for an engineering study is £50,000, and these can last up to 24 months. So in terms of a feasibility study, so the aim of the feasibility study is to investigate a chosen technological solution and the technical, economic and operational impact this technology would have if it was to be deployed. So it's important to note that it shouldn't be carried out as part of an options analysis, and it should be very much focused on a single technology that has already been defined. For deep decarbonisation projects and studies, then you should demonstrate that the technology is sufficient and well developed and feasible to be used in the process. Engineering studies. So the aim of an engineering study is that it is a detailed project plan that identifies specific technical and operational requirements equivalent to a front-end engineering and design study. So it is more in depth than the feasibility study, and the output of an engineering study is expected to be a full project plan incorporating all of the information required to fully understand the project. So running a little bit through now some eligibility requirements, which will give you a little bit more detail. So Ietf does have a SIC code requirement. So in order to be eligible to apply into the Ietf, the lead applicant must undertake categories of activity as defined by the SIC codes here, which is 10 through to 33 for manufacturing and data centres 63110. If you are a parent company though, and your SIC code doesn't reflect the activities being carried out at the project site, then if you contact Innovate UK and we can have a look at that on a one-to-one case, but we do recognise in some cases parent companies will have different SIC codes. Partners in the project don't have to fall into this SIC code criteria, it is just the lead applicant. In terms of the amount of grant that you can apply for, so there's a table here that you can see which is focused on the deployment strand of Ietf, which runs under a certain subsidy rule, and the studies strand operates under a different subsidy rule. So for deployment, to be able to calculate the amount of grant that you're able to apply for, it goes on your company size and also whereabouts your company is located in the area and whether or not you are an assisted area or if you're located outside of an assisted area. There is a map in the supplementary guidance notes that you can click on, and you can type in your postcode and you'll be able to identify which area you're located in and therefore calculate the percentage grant that you're eligible for. For the studies, it operates slightly differently. So this is based on the size of your organisation and whether or not you are applying for a feasibility engineering study or an engineering study with effective collaboration. And you can see the rates here. All of this information that I'm running through now is on in the guidance notes that's on the main Ietf page, so you can refer to it there. In terms of eligible costs, so if you are looking at the feasibility and engineering studies, you can claim for grant support towards the full costs that you'll be carrying out, and largely that's going to be labour, overheads and maybe some material costs, but you'll be able to claim towards the full cost of your project. For the energy efficiency deployment projects, it is slightly different in that you can claim for grants support, but it's only towards the costs directly associated with achieving the higher level of energy efficiency. So as you go through your application process, you'll see you are requested to state a counterfactual case, and that means you have to refer to a similar, less energy efficient solution that you would credibly carry out without the aid. And it's actually the difference between those two costs of the less energy efficient solution and your new energy efficient solution that would be your eligible costs. There are some cases where you can claim towards the total amount of your project, where it's demonstrated its sole purpose is to achieve the energy savings. But what we ask and suggest is that you contact Innovate UK if you would like further clarity around your eligible costs, because obviously that then impacts on the amount of grant that you can claim towards. We have had a number of questions around the super deduction scheme and how it correlates to Ietf projects. So if you are eligible, presumably, for both of the schemes, both the super deduction scheme and Ietf, then you can claim super deduction on the proportion of match funding that you as a company have provided towards the project. So if you've been awarded a 30% grant from Ietf and you're putting in 70%, then super deduction can be claimed on that 70%, but not on the whole project cost. So now I'm going to run through some of the technological scope for Ietf. And we're going to start off, first of all, with energy efficiency projects. If you have an energy efficiency project, you can look to do either a study of your energy efficiency solution, or you can look to do a deployment project. So this slide here gives you an idea of the type of technologies that are in scope for energy efficiency studies or deployment projects. So energy use optimization and recovery as a catch-all is one of those, and that's looking at things like industrial process control, more efficient heat exchange, more efficient drying, energy recovery from waste heat, from waste pressure, resource efficiency to reduce wastage, and optimize use of raw materials. Heating and cooling equipment is also in scope for Ietf if it is directly related to the industrial process. So for example, refrigeration for cold storage of products, or cooling technologies for data centres. Where it is not in scope is when you're looking at heating and cooling for building and sort of staff comfort, if you like. Fuel switching is also in scope for energy efficiency projects, but only where it can be demonstrated that the outcome of the switch delivers energy efficiency improvements, and where the switch is to a less carbon intensive fuel that is also not a higher carbon intensity than the gas grid. So a little bit more info here on the fuel switching. So if you are looking to do a fuel switch project, you can switch from a fossil fuel, more carbon intensive than the gas grid, to the gas grid, or you can switch from any fuel to grid electricity. When you actually go through your application, you will need to show your energy savings, and that's by measuring or estimating the energy consumption and production output before and after implementation. You need to make sure that these are carried out at a site level. There are also TRL levels requirements for energy efficiency projects. So your technology readiness level should be 8 or above to be able to be eligible. And that means that your technology has been proven to work through successful operations or has been qualified through test and demonstration. There are projects that are out of scope and projects that we are not funding. So there's a list of those here. So CHP projects, we're not funding under this strand. They're being supported under the Decarbonisation Study strand, which I'll touch on in a moment. The cost of purchasing, installing and maintaining renewable electricity generation projects, these are out of scope unless it's from waste heat or waste pressure or waste process gas or liquid. Production of fuels, including hydrogen, biogas or biofuel, is out of scope. Repair and maintenance projects, plant closure projects, energy efficiency measures in transportation, and any building improvements, including building lighting, space heating and cooling, that's out of scope, and any new builds, plant or expansions. Moving on now to decarbonisation projects. So for this round, it's only eligible for a studies project, Deployment decarbonisation projects will be eligible in phase 2, which will be announced later in the year. But if you do have a decarbonisation study project that you are interested in, then you need to make sure that these are looking at the facilitation of a permanent installation of technology. So it's not an R&D project or testing of a technology solution. You do need to make sure that your project will result in a significant reduction in the greenhouse gas emissions of an industrial process, but it may not necessarily have an energy efficiency benefit. And again, the TRL level requirements for decarbonisation studies is slightly lower. So this can be TRL 7 and above. So again, it must be proven to work through successful operation or qualified through test and demonstration, but it can also be at a prototype stage or requiring demonstration of an actual system prototype in an operational environment. In terms of the technologies which are in scope for the decarbonisation studies, you can either look to do a fuel switching project or you can look to do on-site carbon capture. So I'm just going to run through some of the fuel switching criteria for you. So fuel switching projects, they'll be supported where you can demonstrate that you are switching from a fossil fuel to biomass, waste or hydrogen, from fossil fuels to biogas, but that's for off-grid sites only. Fossil fuels more carbon intensive than the gas grid to the gas grid, and any fuel to electricity. It is worth noting though that any fuel switching projects which involve CNG or LNG are not supported. So if you are looking at a combined heat and power fuel switch project, there are some rules here. So they'll only be supported if the fuel switch follows the rules that I have just previously run through on the other slide. The output from the CHP project where biomass is used must be used in high temperature applications. Any biogas CHP projects must be off gas grid sites. And at least 70% of both the heat output and the electricity output produced by the plant should be used in the eligible industrial process by the lead applicant. If you are considering a biomass fuel switch project, then these will be supported where it's switching away from solid fossil fuels to biomass, where the source of the biomass is considered sustainable, and the output from the biomass combustion is used in high temperature applications. And again, it's worth noting that biomass projects that are less than 1 megawatt thermal input are out of scope. And then carbon capture projects, anyone looking to do on-site carbon capture. So these will be supported where the captured CO2 might be used on-site or transported and stored. So you must include realistic, economically planned CO2 routes, and where possible include estimates of the energy and carbon costs as well of moving the CO2 to the disposal utilisation sites. But in terms of projects which are out of scope, so any studies for CO2 transport networks or long-term storage, or studies to deliver direct air capture or the development of test centres are not in scope. And again, there are projects as well that we're not funding under this strand. So similar to the energy efficiency strand, renewable electricity generation is not being supported. Production of fuels, including hydrogen, biogas and biofuel, is not being supported. Repair and maintenance projects, plant closures, decarbonisation measures in transportation isn't being supported. Building improvements, again, as I touched on before, and new build plant or expansions. So hopefully that gives you an idea of the two strands, the energy efficiency and the decarbonisation, and what we can and cannot support. I also wanted to take an opportunity to run through with you some of the details of our phase 1 winners, which is very exciting that we're going to hear from some of those a little bit later, just to give you an idea of the type of studies that were, the type of technologies that were supported in phase 1. So we have Hinton Perry and Davenhill, and they're looking at a conversion of exhaust kiln heat for use in drying bricks and tiles. Tate and Lyle Sugars have got a couple of projects, one looking at an adaptation of a calcium looping system to reduce greenhouse gas emissions, and another looking at an innovative low temperature physical separation carbon capture process. Then we have Lang O'Rourke looking at decarbonising precast concrete manufacturing. Sankabane Glass is looking at glass furnace efficiency improvements. James Cropper, looking at advanced waste heat recovery. BAE Systems, looking at process steam improvements. William Cook Holdings, looking at waste heat recovery. Phillips 66, looking at refinery fuel gas with renewable and low carbon hydrogen. And then we have some deployment projects which are coming on stream as well. So Seltzer Manufacturing, looking to deploy a static VAR compensator. SR Oil, looking to deploy a net zero ready furnace. Then we have 2 projects from Rick Bestwick, looking to deploy the next generation of cold store technology. And we have NSERC deploying an end-to-end process control solution. So that gives you an idea of some of the technologies that we're supporting through phase 1, and there'll be more projects coming on stream over the coming weeks and months. So thank you very much, and I'll pass you back over to Jenny.
Thank you very much, Julia. That's great. So again, if you have any questions about anything that Julia's just presented, please type them into the chat box on YouTube, and we'll get back to those after I've completed this presentation on frequently asked questions. So what you've just heard from Julia is going to be in my presentation now, but these are the questions that came up time and time again. So we thought it might be useful to just go through with them, just to highlight exactly what we mean by these questions. So let's get started. So first of all, what are the eligible costs for a deployment project? So the studies competition is nice and straightforward. It's the costs of the whole project are eligible because they're all related to the energy efficiency or decarbonisation that you're planning to do. But for the deployment project, as Julia said, the eligible costs only relate to the energy efficiency improvement part. So it really depends on what you're doing on your site as to whether the full cost is eligible or part of the cost is eligible. So for example, if you were planning to replace some process equipment, such as your furnace or your boiler or a chiller, then you can't claim the full cost of that because that equipment is part of your manufacturing process. Its reason for being is making the product that you make. So the eligible costs are the difference in price between a like-for-like replacement, so another boiler that is of the same standard as the one that you currently have, and the price of fitting the latest, most energy efficient version on the market, which is going to be more expensive than a run-of-the-mill boiler or furnace. It's that difference in price that is your eligible cost, and that's the amount that you can claim grant on. However, if what you wanted to do was that the sole purpose of it was about energy efficiency. So for instance, a heat recovery unit, it's not part of your manufacturing process. You're only installing that to recover that waste heat and then reuse that captured energy. So because the whole purpose is reducing your energy demand, the full cost of that would be eligible and you could claim grant on that full cost. As Julia also said, another question that we get a lot is, am I eligible to lead an Ietf project? So Julia shared with you this idea of these standard industrial classification codes, these SIC codes, that are how we decide if a company can lead a project. So if your company SIC code, and you can find them on Company House, if you put your company name into Company House, on that front page, scroll down to the bottom and you will find your SIC code. If it's an eligible code, great, you can apply as a lead applicant. If it's not one of those eligible codes, but the activities that you're doing on your site, so the manufacturing activities, the data center activities do match the description of the eligible SIC codes, then you are okay to still lead. But I would recommend getting confirmation from Innovate UK before you start filling in your application so that you know confident that you are eligible to lead with that with the activity that is going on your site. Next slide, there we go. And the next question that we have had a lot over since last summer with phase 1 is, well, there's a number of them there, but I've grouped them together. So I'm building a new site, I'm expanding my current site, I'm installing a new production line or a new server room. will the Ietf pay for that new equipment? Now, unfortunately, the Ietf won't fund that. The fund is trying to tackle the carbon emissions that we're already creating. So new build or expansion of an existing site is out of scope for the Ietf. Obviously, if you're building a new site, we would hope that you would try to buy the most energy efficient versions of the equipment that you're putting on your plant to save yourself money in the long run. But unfortunately, the Ietf can't help you with that, the cost of that for new build. The next one that Julia mentioned is around heating and cooling. So will the Ietf fund energy efficiency relating to heating and cooling on my site? That depends again on what you're doing. So if you're reducing the demand for heating and cooling related to the industrial process, so the boilers, the furnaces, the chillers, the air conditioning that is keeping the servers cool, is helping to make the product, then that is in scope and that would be eligible for energy efficiency or decarbonisation. However, if what you want to do is really reducing the energy demand related to heating and cooling across your site generally, so for instance, air conditioning or heating of offices and corridors and canteen, things like that, that isn't in scope. It has to focus on the manufacturing process or the data center process. The next question we get asked a lot is, can I fuel switch to biogas for use in a CHP unit? Well, as you've just seen from Julia, you can only install combined heat and power if you're also fuel switching. So yes, on the face of it, that would be fine. But also the extra caveat for this round of funding is that fuel switching to biogas is only in scope for sites that are not connected to the gas grid. So you can do biogas with CHP as a fuel switch, but your site cannot be connected to the gas grid. And the reason for that is that the government already incentivises biomethane injection into the grid. So the Ietf is happy to help sites that can't benefit from that, but for everyone else, there's already that support, so it's not being covered by the Ietf. Next slide. Oh, apologies there. Eileen, could you take me back, please? Sorry, for some reason the arrows are going in the opposite direction to the way they're pointing. So one more slide. That's it, lovely, thank you. So as you just saw, this last two questions. So can I install energy generation on my site? So the generation of renewable power, so solar, wind, that type of thing, or the production of low carbon fuels like biogas or hydrogen is not funded by the Ietf. The fund won't cover the costs of installing a solar farm, installing wind turbines, putting an electrolyser to produce hydrogen on your site, or AD units. You can apply to do a fuel switching project, which will allow you to look at what needs to change on your manufacturing process to run on the new fuel, but the Ietf won't fund actually the generation of that fuel. The exception to this is the generation of renewable heating and cooling. That is in scope as long as the heating and cooling is directly used in the manufacturing process. So if you're thinking of solar thermal, geothermal, heat pumps, the cost of installing those to provide heat to the manufacturing process or to provide cooling to the data centers, that is eligible for the Ietf. And as we just said, combined heat and power installations only in scope if you're also fuel switching to a fuel of a lower carbon intensity. And then the final question, which I think I'm probably being asked the most out of all of the questions, is can I carry out market analysis and energy assessments as part of my feasibility study? And the answer to that, unfortunately, is no. The modelling of energy demand across your site and a review of all the different technology options that might be suitable for your site is not funded by the Ietf. You have to have already done that kind of initial assessment and chosen the best technology option for your site before you then apply to the feasibility study. The feasibility study allows you to assess the technical and economic viability of installing that particular technology on your site. So at the end of the study, you can make a decision on whether to deploy or not. However, if you need that assistance, you need help to find out what best technologies are available out there. The KTN has a process called the Innovation Exchange, which I'll tell you about later on in the event, and that might help you to find suitable technologies if you're not sure what to do on your site at the moment. Okay, next slide, please. So we're now at the first Q&A session. So let's have a look at the questions that have come in. Aileen, oh, there we go, lovely. I lost the menu at the bottom there for a minute. Okay, so looking at our questions. The first one we've had in was from Reese Finney, and they asked, I am particularly interested in the level of detail required for an application for energy efficiency deployment technologies. Is it sufficient to have a concept design with budget costs or a fully quoted detailed design with supporting mechanical drawings and quotes? So Rob, would you like to take that question for us?
Yeah, sure. Yes, Reece. I mean, it is sufficient to have that, and many do. What I would say is that when the assessors look at the application, the more detail within the scope that the word limit and page limit allows, the better. So if you do have any more detail on technical designs or descriptions that you feel is relevant to it, please do put it in, but it's not obligatory.
Okay, thank you, Rob. Julia, do you want to add anything to that?
Yeah, definitely. As Rob said, certainly include as much information as you can. However, we do recognise that costs that you put in at the application stage could change and vary, because it could be some months before you are informed that you are successful and therefore your project will start. So as accurate as you can be with your costs is advisable. However, please bear in mind that your grant, should you be successful, can never go up, but it could go down. So if your project should increase, if your project costs should increase, then we wouldn't be able to increase your grant accordingly once your application's already been approved. You've also got to weigh up the fact that applications have a value for money score as well. So we do say, you know, don't necessarily claim for the maximum grant that you can do if you don't need to, because then you will get a better value for money score looking at energy saving per pound of grant. So you need to weigh up the value for money element with your estimated project costs. I hope
that's great. Lovely, thank you, Julia. Moving on to our next question from Michael Evans. This one's for Catherine Barber. So with so much focus on the industrial clusters, what is BEIS doing to support the industrial emitters to decarbonise who are located away from these clusters?
Thank you, Michael. Good question. Well, you're very much in the right place here at the Ietf seminar, because we do support projects all across the country. And several of the examples that you'll hear about after the break are from companies that aren't on a major industrial cluster. There are also other BEIS funds that do support people all across the country, and particularly in the innovation programme. We have £1 billion in our net zero innovation portfolio, and most of those funds are also geographically neutral.
Lovely, thank you, Catherine. The next question we have from Abhishek Astana. It's about the deployment competition. So looking to replace gas furnaces with electric induction to increase efficiency. Will the cost of getting new electrical connection cable with greater kVA capacity be eligible under the Ietf? And I think we also had a similar, oh no, that's about heat now. So Lily, would you like to take that electrical cable question?
Sure, thanks. So essentially Ietf will support any of the on-site adaptations and investments that would be needed in order to deliver the energy efficiency or the decarbonisation outcome. So in this case, what you've suggested sounds like it would be in scope, and we would be able to support the investment in any cabling that was needed within the boundaries of the site. So we couldn't support, for example, any cabling that might be required in order to connect to an external grid network, where that would be outside of the boundary of your site. But if it's directly associated with the industrial process and it's within your site, then that would be in scope for funding.
That's great. And the next one's similar, even though it's about heat networks. So Samuel Benjamin said, are connections to heat networks for industrial process heat supply eligible under Ietf?
Yeah, so it's a very similar answer. So again, we will essentially be supporting the on-site investments. In the case of heat networks, we do have a specific rule where we strongly encourage applications for heat recovery and use of that heat within industrial processes, but we do limit that usage so that the full scope of the project needs to be within an industrial site. So you wouldn't be eligible if you were capturing heat and then exporting it to an external heat network. You would, I think there's a follow-up question actually that's quite similar, and perhaps we can cover that as well, which is whether you'd be eligible as a site to switch to an external heat network that might be providing you with your energy supply. And again, that would be in scope in as much as that would fulfill the requirements of our fuel switching criteria. So provided that you're switching away from a more carbon intensive fuel to that recovered heat or that heat from the network, that would be in scope. You might want to consider whether that would constitute an energy efficiency project. So would you be reducing your energy consumption, or would it fit more perhaps with our decarbonisation competition, which would be opening later in the year? So I think that would be one of the major considerations there.
Lovely, thank you, Lily. Next question is from HGD. Are universities eligible to lead or participate in the Ietf? So Julia, would you like to answer that one?
Yes, of course. Unfortunately, universities are unable to lead, but yes, they can be a partner in a project.
Okay, thank you very much. So if anybody else, if you have more questions, please do type them into the chat box in YouTube. Our next one is from David Knight. Energy efficiency on cooling. So we have a new technology that replaces traditional radiators or cooling towers using heat in the fluid gas to power cooler. Would this be covered by the fund? So installing this. That's a little bit of a project specific question. So I might ask David to book a one-to-one with Julia or BEIS to talk about that in more detail, because it's probably easier if we have a little bit more of a information about how it would work on a site. So if you don't mind, David, I'll ask you to sign up for a one-to-one for that one, unless anybody from BEIS or Innovate wants to have a stab at that.
I was just going to say that obviously cooling technologies are in scope for Ietf, providing they are directly related to the industrial process, but it's always advisable just to run your whole project past us, and then we can advise you accordingly on that.
Lovely, thank you, Julia. So we have an anonymous question now regarding the value for money score. Is that a £1 per kilowatt hour saved, or is it based on the £1 per tonne of CO2 equivalent saved? So again, Julia, would you like to?
Yeah, so the value for money score is a combination of both. So when you look in the on the guidance notes of how to apply, you'll see the different weightings as well of the scoring against the different questions, and certainly in the project benefit question, there is a weighting for energy efficiency, and there is a weighting for your sort of decarbonisation side as well, and your carbon reduction savings. So the value for money score is calculated as a percent, taking into consideration both of those. Lovely,
thank you very much. And our last question at the moment, I think. Oh no, we've got a new one. James Mitchell. Hello, apologies if this is, I think this has already been covered, but we'll read it out for you, James. Would replacing a gas-fired furnace for an electric furnace be eligible for funding? So Lily, would you like to take that one?
Yeah, absolutely. So that would be eligible. I think, again, you probably want to consider whether the main outcome of that fuel switch is an energy efficiency saving. So are you reducing your energy consumption by making that switch? or are you sort of achieving more of a decarbonisation benefit for your site? If it's the latter case, then you might want to consider applying in the later phases of our fund, so phase 2, which will open later this year, where we'll be supporting the deployment of decarbonisation technologies. You'd also be eligible in this current phase to look at a feasibility or an engineering study to look at that technology as well. Julia, I don't know if you'd want to add anything else there.
No, not at all. That's absolutely fine. And again, please don't hesitate to contact us specifically about any project details.
So I think that is it for the questions. We've not had any more come in for a little while. We do have another Q&A session later on, so I'll call a halt to that now. So we're going to stop now for a short comfort break. We've got more time because we finished a little bit earlier. So have a nice walk around the garden and a cup of tea. Don't forget that if you do want to have one of those one-to-one confidential chats with either BEIS, Innovate UK or myself, you can do that, particularly around specific project ideas that you have. If you just want to run it past us and see if that would be eligible, it's a lot easier in a one-to-one situation for you to be able to describe exactly what you want to do. Then please do register at that link. When you register, you'll receive an email with your login details, but please remember to activate your account as well, which is on that email, and then you'll be able to find us in the networking platform to be able to book a one-to-one meeting. I think that's probably it for now. I would say as well, it doesn't have to be just about projects that you want to do now. You can also use these one-to-one meetings to be able to give BEIS some feedback on what you would like to see in future rounds of the Ietf. So if, having now seen the scope of these competitions, there's anything new or extra that you think would support you to decarbonise or reduce your energy demand, then this is also a good opportunity to give them that feedback. So I'll leave it there. Thank you all very much for being with us this morning, and I will see you again at 11:20. Thank you. Well, hello everyone again. Hope you got a chance to log on and book a one-to-one with BEIS and Innovate UK for later on today. We're now going to, I'm very pleased to say, going to have some presentations from some of the projects that were funded in phase 1. And we're hoping that this will give you some ideas of what you could do on your site, but they're also really great projects as well, which I'm sure you'll be pleased to hear about. So first of all, we have Sebastian Roginski. He's the engineering manager at Sangerman's Glass site in Eggborough, and he's going to talk to us about their planned deployment project looking at a furnace replacement. So over to you, Sebastian.
Thank you, Jenny, and good morning, everyone. I'm really pleased to be able to present to you the project that we are currently undertaking here at Eggborough. And the next few slides are going to cover how we've established this project and what we've managed to do to secure the Ietf grant, and fundamentally what we've learned as part of the process. So can I have the next slide, please? Okay, so our site is located in East Yorkshire, quite a large industrial site, 75 acres. We employ around 200 employees, and it's a very advanced plant already that was built in 2000. We have got a very long line, over half a kilometer, that we use to produce continuous glass ribbon, 3.2 meter wide, and the thickness range is between 2.9 and 12 millimeters. So we produce around 185,000 tonne of glass per annum. It's a continuous operation. Furnace hardly stops, and it has been in operation for 21 years until this April. We also on site have got a coating line and a laminating line. Can I have the next slide, please? So just a little bit of background to the process and the project. So we take raw materials that are delivered to site. We then mix them and prepare them in the batch house, and those are then delivered to the melting furnace. That melting furnace, over 40 megawatt power furnace, uses a lot of energy to melt raw materials, which are then refined and poured onto a molten tin, where we spread the glass to achieve the thickness and width, and ultimately we lift it out to the tin bath and cool it and anneal it in the layer before sending into the cutting line, where the glass is cut to the required size. Can I have a next slide, please? So this line, as I've mentioned, is now 21-year-old, and at the time it was state-of-the-art equipment, but things obviously move on, and we had the furnace coming to the end of its serviceable life, and the furnace required a lot of maintenance to get it to this stage. And we started looking at replacement some time ago last year. So can we have the next slide, please? So when we started at this replacement, it was a case of looking what we've got now, and we will replace it like for like, which is for the Ietf purposes counterfactual case, and that alone would have been nearly £30 million investment. But also the technologies now exist, and we developed patents within the group that have been proven that can deliver furnace and line efficiency, but that required additional investment. We learned about the Ietf grant through the publications that KTN and Ietf did, and started exploring the options what we could do. We've engaged our management within the group, whether we would want to proceed with that kind of application, and had the support, and started the process. So through working with a consultant, but also the team from Jenny and others within the Ietf, we've managed to prepare a presentation and an application that showed that we can deliver improved energy efficiency of the line, driven by the reduced natural gas consumption and the furnace glass output, increase the line capability, so pull the glass, reducing gas consumption per kilogram of glass produced, reduce the CO2 and other pollutant emissions, and also, which is a consequence, reduce the scope of glass imports and transport CO2. Can we go to the next slide, please? So you remember this schematic from previous slide, and I wanted to briefly show you, what we included in our scope. So in the batch plant, we looked at what is required to upgrade the equipment to enable the efficiency of the furnace and of the line to be realized. So that was in scope. But as you can imagine, as part of the 30 million scope, we are doing a lot more. So we had to be very careful in terms of what we will include in the scope for the grant eligible costs, and what is essential maintenance or essential replacement. The key part of the energy efficiency improvement is the furnace. So the furnace includes changed design on a very similar footprint, which includes patented solutions in the regenerators and also in the melting zone of the furnace, which we've proven within the group that delivers the efficiency required for us to realize what we're going to deliver in this project. But also there are other aspects required to realize this, which is the utilities upgrade, for example, cooling system, as well as the control system to control all of this. So that has been in scope. And then further down the line, on the float bath, we haven't included anything in the scope because we're not changing anything that delivers an efficiency improvement, energy efficiency improvement. But on the layer, we had to redesign the layer and essentially enable the pull to be realized and the efficiency from the furnace to be realized, as well as in a similar approach in the cutting line to be able to return the cullet back into the batch plant at the higher rate. We included some of that scope as well. Next slide, please. So the project details. The investment is over £30 million. We identified over 4.7 million of eligible grant costs, and that was in discussions between the project team and also clarifications with the Ietf team. And that ultimately will, once the process is completed, will enable us to claim the grant value of 1.4 million. So in terms of benefits, the annual minimum reduction of gas consumption is going to be around 75,000 megawatt hours. And that was based on like-for-like output in 2018. And obviously you've got to have the reference to apply for the grant and state the assumptions in your application. So that's what we did. And just to maybe add, we are now going through the monitoring and verification process when we are setting up how we will monitor the consumption going forward and what variables will be taken into account, because we are manufacturer and things can obviously vary depending on the demand for the product, for example, but also what's happening on site, maintenance, etc. And there are some, good consequences. So obviously, lifetime estimated reduction of greenhouse gases, as well as with the increased efficiency and the design change, we are also able to realize uplift of the productivity on our line. Next slide, please. So I wanted to highlight you some of the challenges, but also considerations. So the new furnace design and the patents that we've developed within the Saint-Gobain group and proven them in the projects that were delivered were available, but that didn't mean that Eggborough site would have those deployed and realized, because for example, the previous furnace rebuild that was done within the group was like for like. So it was absolutely essential, and my role and the team that we had working on this application to secure this application to enable us for these efficiencies to be realized and get the different design of the furnace. We spent a lot of time, and the project team spent a lot of time ensuring that we get value for money. So and we applied the best practice in procurement to get the competent but also competitive tenders for the installation of the work, and that was achieved by the team that we've created and is led by my predecessor, previous engineering manager for the site, that is currently executing the delivery of the project, as well as the seconded personnel from central team in Paris and contracted staff. And the Ietf application itself is a task, and it has to be done well, and it has to be done with the right scrutiny and details. So one of my project engineers, project manager, has been working on this with my sponsorship, and we had support from a consultant, because we were doing this work first time, and that has been very helpful. The team in Ietf has been very helpful answering our questions, and certainly helped us on the journey. So the project itself, there was a lot of planning before we started the project, but we're now into project execution. So we signed the contract with Ietf, and we're in the execution phase. And then after the furnace is rebuilt and the line is started, we will have another 4 months to close the invoices. Next slide, please. I just wanted to share with you some points for consideration. So as previously covered by others, we be clear on your costs and what's included in the scope, what's not included. We spent quite a lot of time trying to understand this and define. So, for example, if you're doing maintenance that we would do normally, that's not in scope. As we've learned, and it has worked out for us, the project starts at the effective date of the contract between Ietf and applicant, not before. So and there is evidence of the money leaving bank. So, plan ahead into your application that the project doesn't stop when you've completed the execution. It's also the invoicing and money leaving and also processing of the claims. When you're writing your application, focus on answering questions asked. Don't just fill the box. Just think about what you want to say, and also consider the scoring matrix, how this is going to be scored, and what you're trying to answer to enable the people that will assess it to give you the best possible score for the project you're doing. In terms of getting the project ready, we've learned that we had to assume some costs, some prices. It's really good to get quotes early and know how much things are going to cost, because then potentially you might need to be recategorizing things, or some of the costs might not be realized. And finally, the team at Ietf is really good in clarifying points and answering questions. So please get in touch with them for the one-to-ones that have been offered, or via email, and get the support for your application. Thank you.
That's great. Thank you very much, Sebastian. Thank you very much for the praise as well. But the support services are there to help everyone. So it's good to see that it worked out for you guys. So we'll take questions for Sebastian once all of the 4 case studies have been presented. So I'd like to move on now to Tim Shire. Tim is the Energy Management Technologist for SR Oil at their refinery at Stanlow, and he's going to talk about their net zero ready furnace replacement. So I'll hand over to Tim.
Thanks, Jenny. Okay, if you want to go to the next slide. Just give a quick overview of what we do and our kind of decarbonisation roadmap, and then how this project fits in as part of that. Then one of the things that Jenny and the BEIS team wanted was to try and give projects that might be applicable to other industries. So I'm going to talk about some of the principles of furnace efficiency improvement, and hopefully there'll be something there that you might think could apply to your site. And then I'm going to talk about our specific project, that there's actually some quite close similarities with what Sebastian just talked about. But I'll talk about our project particularly and our experiences of the application. And then, as Jenny said, there'll be questions at the end. So if you go to the next slide, please. So Stanlow is an oil refinery. So we produce 16% of the UK's road transport fuels. And we also provide a lot of chemicals, chemical feedstocks for the Northwest area. We also supply fuel, steam and power to other companies in the industrial cluster up in the Northwest. So we're kind of very much, our industry is going to change a lot with the energy transition, and we've got quite a lot going on. So if you go to the next slide. So, you know, we need to decarbonize our manufacturing. And so that's the site itself. And we've got quite ambitious targets for doing that. We also need to decarbonize the products that we make. And we've got various sort of projects and alliances going on about, you know, basically selling less fossil hydrocarbon and more alternative fuels. Now, there's been a lot of hype about the HyNet project, which is a sort of low carbon hydrogen cluster in the Northwest. And that's kind of a magic bullet to decarbonize. But I think something I wanted to really make clear was, if you look at our decarbonisation roadmap, so we currently emit about 2 million tonnes of CO2 a year. So we're a top 20 emitter in the UK. Changing to firing hydrogen and carbon capture makes a big impact, but it's actually going to add to our costs, right? The hydrogen will be more expensive than the fuel that we burn now. Whereas energy efficiency, we think there's probably about 400 kTA of carbon a year savings that's sort of practically possible. And that will not only decarbonize, but it will reduce our operating costs too. So really it's a sort of a priority for us to do some of those things. And we've got, I mean, it's a very large site. So we've got a couple of hundred incremental ideas on the list that we're trawling our way through. And we also have some transformational kind of projects that are maybe big scale or a real big step change in the way that we run the site. So there's a couple of major projects, and the grant is funding this furnace replacement is sort of the first of those transformational projects. We've got various kind of interesting barriers. So we generate fuel as a byproduct, and then we generally make our own power and steam on site. And as we look to do some of these transformational projects, things like heat pumps, things like changing steam turbines to motors, electrification, that will change our steam balance and change our power balance a lot. And there's quite a lot of sort of technical constraints around that. So we're planning a CHP that could be hydrogen powered. And those kind of transformational projects all need to be considered together. Eventually, energy efficiency will kind of reach its technical limits, and then we're looking at carbon capture and hydrogen firing to go the last piece. So if I move on to this furnace replacement project, if you go to the next slide, please. So sorry if I'm teaching anyone to suck eggs here, but I guess this project, although it's very large, so we're talking in our project a 100 megawatt furnace, or more than 100 megawatt furnace. It's conceptually pretty simple, and it does apply to all kinds of fired equipment that, you know, all kinds of industry would have on site. So furnaces, boilers, incinerators, dryers, anywhere you're burning fuel, the principles are much the same. And if you look at a furnace, almost all the energy losses are in the hot flue gas that goes up out the stack. And there's really two things you can do to try and improve that. So the first thing is, if that flue gas is going out hot, so typical figures you see in industry are like 150 to 300 degrees C. Well, all that air and fuel has been heated up, and that's just heat going up into the atmosphere. And so if you can recover some of that heat and send it out colder, down to 150 degrees or less than 100 degrees C these days, then you can get that energy back and make a saving. One of the constraints possibly is the ADP, the acid dew point. So you have to think about corrosion, but that's a kind of big source of lost energy. And then the other way that furnaces become inefficient is basically having too much flue gas. So you need a certain amount of oxygen to combust the fuel. So there's a minimum sort of stoichiometric air. But if you think about air is 20% oxygen, 80% nitrogen. So every extra molecule of oxygen you put through that you didn't need for combustion, there's 4 molecules of nitrogen getting a free ride through there that you're heating up and then end up going up the stack. So trying to control that excess O2 in the flue gas, again, typical numbers you see in industry 3 to 8%, but best practices down to about 1%. You can't go really below 1 because you get incomplete combustion. So that's something else that can be optimized. So there's various formulas. There's a formula on the screen for how you can kind of quantify the opportunity. If you don't have instrumentation, you can kind of get handheld flue gas analyzers and stick it in there and see what the gap might be. But kind of rules of thumb, 20-degree reduction in the flue gas temperature is about 1% efficiency increase, and a 2% reduction in stack O2 is about 1% efficiency increase. So when you kind of work this out, you typically see fired equipment efficiency, between about 70 and about 95% efficient. So there's room to improve. And there's various ways that you can improve it. So the oxygen is generally improved through monitoring and controls. So oxygen analyzers, carbon monoxide analyzers, that allows you to run closer to the wire and detect incomplete combustion very quickly. Improving the dampers, variable speed drives, also stopping air leaking into the furnace. That's another source of loss. And all that kind of monitoring and controls is kind of well established, but there are a lot of industrial furnaces that don't have very sophisticated O2 control, so you can improve. And there are also new technologies. So for example, TDLS lasers, and this for very big furnaces like we've got, on our old furnaces, we're sampling oxygen. We've got a little tapping on the side of a really huge furnace that could be 10 meters across, sucking out a little bit of the sample away to an analyzer. And that's quite slow because it takes a while for the sample to reach the analyzer, so you can't control that tightly. And also, it's only taking a spot sample out of this big box. So things like the laser, TDLS laser, it shines a laser across the whole firebox, and it can detect the kind of average oxygen across the whole thing. And it's a very instantaneous measurement, so you can get improved control. And then improving the stack temperature. Basically, you're looking at improved heat recovery, and there's many different ways you can recover heat. You can generate steam, you can generate hot water if you need that on site, you can increase your process heating, or you can preheat the air, so you recover the heat from the flue gas into the air that goes into the furnace. So lots of different options there. Again, there are new technologies emerging. So there's polymer air preheaters now, so you can go below the acid dew point because they don't corrode. So you can really sort of extract everything. So that's kind of, as I say, just the kind of basic overview. And let me talk about our furnace in particular. So if you go to the next slide, please. So we had a very large furnace, more than 100 megawatts. It was originally designed to burn fuel oil and partially converted to gas firing. So it's about 46 years old and running at okay thermal efficiency at 86%. And we had to do some work anyway. So again, as Sebastian said, we had to make some investments, actually some tens of millions of pounds investments to improve NOx, to repair this asset every time we do a shutdown. there's quite a lot of repair work needed because it's so old. And so we had kind of two choices. We had the counterfactual case, which is the sort of bare minimum that we'd have to spend, new burners, new repairs, and that wouldn't have improved the efficiency. We'd have patched up a furnace, it would still be 46 years old, and we'd have, you know, ongoing high maintenance costs and threats to the reliability. So our second option was a kind of transformational project. So basically, the idea is a completely new furnace. We improved the efficiency to 92% immediately. We also have we've left provision, we can make it a bit higher, but due to the sort of time constraints and the outage duration, we're not doing that in the first go. The second thing is we're eliminating the liquid fuel firing, which is high carbon and high cost, but we're also making the furnace hydrogen ready for the future. So when we've got HyNet on stream, this furnace will be a major consumer for almost a third of the HyNet phase 1 hydrogen. We hope to improve reliability, and we make an immediate carbon saving of 20 kTA and 10% of the site use 220 kTA after we switch to hydrogen. The problem is that the transformational project is over twice the cost of option 1, so over 40 million pounds investment required for option 2. So again, similar to Sebastian, we've applied for a grant to cover some of the portion, some of the delta between the counterfactual that we had to spend anyway and this transformational option. So if you go to the next slide. So just to kind of summarize, so we've got quite a big grant, and it allows us to make this sort of best long-term investment rather than just patching up the furnace and limping on for a few more years. We were kind of able to do this step change and make a big change. Our experience of the application, similar to what Sebastian said, we weren't put up to this. BEIS were very helpful, very clear, timely advice. On the last day of the application, we had last-minute questions, and they were very quick at getting back to us. So it was, very, very clear and helpful. The application process is quite thorough. There's quite a few questions that you have to answer, but there's nothing unclear, or I don't think anything too difficult to answer. We considered using consultants to help with the application, but in the end, we just did it ourselves. One thing that really helped us was we'd done a lot of engineering work. We had quotes for different options from vendors before we started. So, we had basically a front-end engineering design done. And I think if we tried to do that during the application process and get some quotes and sort it out, it would have been a bit of a scramble. So yeah, that having the upfront work done was quite key to it. And also we weren't sure if we were trying it on a bit. So I think our grant is about £7 million, which is a big chunk of the overall fund. And we wondered if we were being a bit overambitious, and we were glad to see, this kind of large, ambitious bid was successful. So that's good. And in future, I mean, we've got 9 other furnaces on site, not all as big as this. Some of those we might be able to eliminate, but some of those are candidates for similar improvement, probably not complete replacement, but revamps in later phases. Okay, so if you go to the next slide. So again, I think questions are later, but I'm happy to answer any questions or discuss.
That's lovely. Thanks very much, Tim. That was a great presentation. So we've seen our 2 case studies of funded deployment projects, and we now have 2 examples of the 2 funded studies projects to show you. And before we get into the next one, just a quick reminder, if you have questions for Sebastian or Tim, type them into the chat box on YouTube right now so that we get those across and they can have time to review the questions before the Q&A. So next, I'd like to introduce you to John Kerr. He's the Vice President for Research and Technology at Trl Levels Sugars, and he's going to talk a little bit about their study to look at using cryogenic carbon capture. So over to you, John.
Yeah, thanks very much, Jenny, and hello to everybody on the call. Trl Levels Sugars, part of the ASR group. Sorry about the long title, but it does what it says on the tin. So this is a feasibility study looking at the application of advanced cryogenic carbon capture to smaller scale and dispersed industrial sites. So this is distinct from some of the industrial clusters we were talking about earlier. And cryogenic basically means using very cold technology. The photo at the bottom is our site at Thames, on the Thames in London, and East End of London, close to City Airport, if anyone knows that. And those two stacks are our flue gas emission points, and we're a gas-fired facility at the moment. And I just want to tell you a bit about this technology. So next slide, please. So really, as the other speakers have alluded to, I think we're all in a similar situation here where we're trying to think about how we get to net zero 2050. And in our case, how do we decarbonize our sugar refinery? And as the other two presenters talked about, we've got a 3-pillar strategy as well: energy efficiency, use of non-fossil fuels, and carbon capture to mop up any residual CO2 at the end of the day. The study we're doing is, there's 3 of us in this consortium, who put the application into Ietf, ourselves, Trl Levels Sugars, PMW Technology, and they've got the IP on this technology, and Fichtner Consulting Engineers. And we worked together as a team to put together the Ietf application back in August, September, October last year, 2020. Thankfully, the application was successful and the project started already. And in fact, it's a 4-month project, and it started in May and runs through to the end of August. And this is a really valuable project for us, a really exciting project, because we want to take a really good hard look at this technology and see if it's going to be viable for our future. Thank you. Next slide, please. So A3C is a shortened way of saying this technology. The main attraction, one of the main attractions to us for this technology was that it's a chemical-free nature, and also its relative simplicity. It's got a modular construction. And as I say, the energy needs are quite simple, and it basically needs green energy from green electricity. We think this is one of the next generation technologies. And I think, again, most of us on this call are probably thinking about, do I reinvest in old technology, or do I take a step forward into the future and invest in something that's coming down the track and is actually going to be future ready up until 2050? So we're thinking about this in those optics, and we want to do something that's going to be long lasting and really beneficial to UK PLC. We're looking at potentially abstracting 80,000 tonnes a year of CO2 at our Thames refinery, but clearly we might do some of the other things that we've talked about as well on the 2 other pillars in our strategy. One real advantage of this technology that we're looking at here, the A3C technology, is that it captures really high purity CO2, either from our gas turbine or gas-fired steam boilers. And that's a really good thing for us because, as I said earlier, we're not in an industrial cluster. So we're really focusing on reusing the carbon dioxide that we capture and actually think about it as a food product or indeed a medical product. So one key advantage of this technology is it could be used for really high grade applications. Next slide, please. Now, I'm sure everybody on this call is well aware of how most classical carbon capture technologies work. Essentially, that green rectangle on the left-hand side there is a flue gas coming out of anyone's site, and that's typically, as alluded to earlier, that's typically 6 to 10% CO2, and the rest is nitrogen. And classically, that goes up the flue stack, and to capture it, you need to basically put an absorbing medium in contact with that flue gas. So I'm calling that absorbing medium X, and X is a countercurrent medium that flows around and captures the CO2. And then at the bottom there, you have X plus CO2 or X CO2, and then you basically warm up that material or do something else to desorb the CO2, capture the CO2, and that frees up X again to go back around the loop. So that's your kind of classical amine solvent technology that's commercially available right now. Next slide, please. So what's different with this new novel technology that's been patented in the UK? The really cool thing about this, no pun intended, is that it takes advantage of the fact that carbon dioxide sublimes at minus 78.5 degrees centigrade. So instead of circulating a solvent around the system, you can circulate very cold beads. They can be metallic beads or ceramic beads. And essentially, if you look in that middle box, when those beads come in contact with the flue gas, they capture the CO2, and the CO2 is frosted onto the bead, just like dry ice. It is dry ice. It's crystallized out, and then those beads move forward into the next stage. They're warmed up gently, and they desorb the CO2, which is now very pure, and there you have a very pure carbon dioxide stream coming off on the left-hand side. The beads are then freed up to go back around the loop. They're cooled down at the top again, and then they go through the flue gas, and then the cycle just repeats itself. Next slide, please. So where are we and what next? As I said earlier, we're practically a third of the way through the project. It's been a really good project so far. We're working very closely with our partners. We're working on a full-scale detailed design for our Thames refinery. We're also looking at logistics around the refinery as well. As I say, we're based in London, so we're trying to make sure everything's as environmentally friendly as possible. In combination with the other two pillars of our strategy, we're hoping that this technology will enable us to get to net zero 2050. We're also thinking about expanding this out to other assets in our group if successful. And then, as was mentioned earlier, transportation is out of scope, but this technology can also be applied to shipping, international shipping as well. And we're working with PMW technology on that as well with FICNA. That'll come after this main project that we're working on here. So PMW technology, Paul Wilson, he's the inventor of the technology, and we're all working very well together. I'd like to reiterate what the other speakers said. BEIS, Innovate UK and KTN, everyone's been really, really helpful. Innovate UK, and just give yourselves time when you're making the applications, because it does involve paperwork and you just have to be prepared. Next slide, please. That's it really from me, guys, everyone on the call. If you have any questions, feel free to ask me them and I'll answer as best I can. Thank you.
Thank you very much, John. That was great. So that's a great project, particularly focusing on the decarbonisation theme. So it doesn't have to just be about energy efficiency. You can look at some of the decarbonisation technologies and systems to help you decarbonise. So the last of our case study presentations now for this afternoon, again, another study is from Hinton, Perry and Davenhill, and Alex Patrick Smith is the managing director at the site in Dudley, which is not far from where I was brought up. And he's going to talk about their plans to do a heat recovery study. So over to you, Alex.
Thank you very much, Jenny. And hello to you all on the call. As Jenny mentioned, my little talk is going to be on our Ietf grant application, which is a feasibility study, and we're looking at recovering the kiln exhaust heat for upstream drying of our bricks and roof tiles. Next slide, please. So our business, which is called Hinton, Perry and Davenhill, sounds a bit like a firm of solicitors, but we are actually a manufacturing business, manufacturing clay roof tiles and engineering bricks fundamentally, and derivatives of that, clay pavers and quarry tiles and the like. And these are used for a lot of restoration projects and also new builds in various situations. We're based in Dudley, in the West Midlands, and have operated from the same site since 1805. And there's a little shot there of the factory over 100 years ago. And we're a family business, classed as an SME, so very different from the other businesses that provided their very interesting case studies prior to this. We employ 65, actually today 66 people, and we operate dryers and kilns using natural gas, and operate 5 large and 3 small intermittent kilns and 1 tunnel kiln, and that's a shot at the bottom there of our clay roof tiles coming out of the tunnel kiln. And next slide, please. And our current position is that we emit over 8,000 tons of CO2. And recently, I sort of had this put in a bit of context for me when I was asked to imagine, what that physical mass actually looks like. And 8,000 tons, that's 8 million kilograms. And for us, in terms of bricks, a sort of standard brick is just somewhat less than 3 kilograms. So that's 3 million bricks, and that takes up an awful lot of space. And so that sort of really set the challenge in our minds. What do we got to do to bring this number significantly down? And currently, we only recover waste heat from the cooling cycle from our brick firings for drying of bricks during a limited part of the cycle. And the reason for this is obviously the products of combustion are within the waste stream that's going up the flue during the firing cycle, and we can only really use the heat from the cooling part of the cycle. But also our products that we're drying are very sensitive to the humidity and the heat that's applied. So we can only use that heat, which is very dry, towards the end of the drying cycle, so to avoid cracking of the products that would happen if you hit them too hard too early on. And we use virgin gas in our dryers for the bulk of the cycle. That's not delivered by, with the rest of it for the bricks. That's not delivered by the waste heat, but all of the cycle for our roof tiles. Next slide, please. So the challenge for us is this pathway to net carbon zero 2050, and we want to continue firing with natural gas to enable us to make the same products that we always have. And the reason for that is that we use a reduction atmosphere in the kilns to generate the colors. So our Staffordshire blue bricks that you can see in the shot there are subjected to a reduction atmosphere at peak temperature, which is around 1150, 1160 degrees sometimes, and that converts the ferrous oxide within the clay to a ferric oxide and fixes that color blue, and we play around with that to generate multicolors and so forth for our roof tiles. And we're an old site with a range of equipment with a layout of that's really quite dispersed, and I look rather enviously at some of those slides of factories on greenfield sites where everything's laid out in a coherent straight line. We've over the years had to put new plant and equipment into places where the space existed, which delivers a sometimes less than ideal layout. We've looked at hydrogen and electric kilns, and they don't really seem viable for our processes. We're concerned about embrittlement of steel with hydrogen, and electric kilns don't allow us to reduce. So we don't see that as a means of creating the same products that we currently do now. And in terms of the challenge, for us, the first thing we need to do is reuse all the available energy that we currently waste before looking at other solutions. Next slide, please. And so the project, well, we're running a feasibility study to determine the requirements to use a major thermal processing heat exchanger to collect the kiln exhaust flue gases and the heat within them, to absorb that heat into hot oil and deliver the heat to the drying chambers, and then release it into the recirculation airstream used for drying. And the sort of big part of the task is to study the amount of available heat across the whole year and whether it's sufficient for all our drying processes. And I mentioned earlier we've got intermittent kilns, so we need to map the firings, and we've taken a reference year for that for each one of our kilns. And bearing in mind they are sometimes firing different products, so they'd have different firing cycles. And then within the firing cycle, you've got different periods delivering different amounts of heat as the temperature ramps up, and then the dwell time at peak, and then when you're cooling down. And that has to be mapped for all of our firings, for all of our kilns, and then overlaid to the requirements for the dryers, where again a profile for drying different heat requirements at different times of the profile. So this is quite a job to get that whole mapping process working, which then can be the basis for the assessment of the technical, commercial and engineering aspects of the project. And we're looking really to determine the resources through this study needed for the deployment of this technology and solution. Next slide, please. So the overall aims and objectives of the project is really to confirm the viability of this study and implementation potentially of the technology that we're looking at, and to assess whether there's sufficient waste heat that exists to remove the gas burners and in the dryers and replace them with local heat exchangers, which would save 900 tons of CO2 per annum. That's 12% of our total. And also you've got to we're sort of looking at assessing how the heat exchange technology operates in the rather aggressive environment of our kiln flue gases, and their suitability in the environment also of the dryers, so the secondary heat exchangers which release the heat that's captured. And also we are investigating modifications and testing our drying cycles to accommodate the new heat source. We have gas burners in our dryers currently, and we need to maintain a turbulent atmosphere in our kilns to make sure there are no pockets that have moist air that affect the drying, because our products are absolutely critical. Bricks with 2.5% moisture content or above will explode in the kiln, creating quite a mess to clear out. Next slide, please. So for the grant application, we've applied with a partner, Ceramic Drying Systems, and also two subcontractors, Thermal Fluid Dynamics and Synergy. Thermal Fluid Dynamics will be doing all the detailed calculations and looking at the means of citing everything in the configuration that's necessary to deliver this system, and Synergy are doing sort of stack monitoring for us 24/7 over the period of our firing to test everything that's coming out of the flue. And we chose our partner due to their experience and understanding of the industry and our dryers and kilns. And as been alluded to, there's a lot of work to put these grant applications together, and we, had many conversations developing the work packages that were going to form the basis for this grant applications and the costings for the study, and there was a lot of sort of bouncing backwards and forwards with that, and I think the choice of partner is really important for that part, because it is being done on spec, and you're not clear whether you're going to ultimately get the grant application succeed through this whole exercise. So there needs to be a good deal of trust developed with the partner. And we've received funding for 60% of our eligible costs, and we sought this Ietf funding to de-risk the project, as it's complex, and it's in areas that were unfamiliar to us. Our skills are in manufacturing clay products fundamentally, and this has been really a helpful catalyst to move the sort of thinking and really put some fuel into the trajectory towards decarbonising our business. Next slide, please. And so, the goal for us as a business, and this project sitting within that is to form part of the transition to the requirements of net carbon zero 2050. And over our history, we've transitioned from coal to producer gas in 1935, and producer gas, for those who don't know what it is it was steam, which is passed over coal that's hot coal, and it actually went into a very efficient kiln that we had at the time, which sort of helped secure our future in that period. It did have some downsides, though. It produced a lot of tar, and at various points you had to shut the whole kiln down and chip the tar away, and also obviously these gases were emitted into the atmosphere as well. And in 1971 we transitioned from producer gas to LPG, and then when it became available as mains gas, we transitioned from LPG to natural gas in 1978. And as a business, we're aiming to also decarbonize our firing technology, and ensure all available heat is used in upstream processes. And for the sort of decarbonisation of the firing technology, we see really carbon capture and ideally use as the means to achieve that. And that's really an area that we are going to look into a lot more detail subsequent to this project. But I think for us, for reasons I mentioned earlier about the fact that we can't use hydrogen, and electric kilns don't seem to be a way forward, we need to capture the remaining CO2 that's going up our stacks. And the government regulatory activity, UK TS and climate change agreements and legislating for net carbon zero are sort of important parts of this journey to tackle climate change. But alongside that, support from government has a big part to play to secure the future of energy intensive businesses like ours, and this funding is absolutely vital, and we're very grateful to have received the funding that's been part of this grant application. And I would also reiterate what has been said by previous speakers, that the team, KTN, Innovate, and BEIS have all been really very helpful in this journey. Thank you very much.
Thank you very much, Alex. That's great. So if the four speakers would like to now put their cameras back on, so we'll do another Q&A now. I have one question for all of the speakers, if you'd like to answer this for me. So I know some of you said that the funding helped you to de-risk the project, but what do you think was the main barrier that having the Ietf funding allowed you to overcome, whether it's an economic barrier or a technical barrier, or helps with the payback period? Do you think this would have happened without the Ietf funding? So Sebastian, would you like to go first?
Yes, Jenny. For us, it was essentially securing the backing for the large investment. So it would have been a large investment on the site anyway, and when you're trying to ask for that extra, there is always in a corporation so much money to go around, and everyone is trying to have a slice of the cake.
Mm-hmm.
So having secured the fund, the grant funding was enabling step for the technologies to be deployed in here, and us securing those additional funds.
That's great, thank you. And Tim?
Yeah, I think for this particular project, it was primarily an economic barrier, just the scale of what we needed to invest. Even the counterfactual was making eyes pop out, so finding more money, especially during COVID, was difficult. But I think as well as that, just because it had that link to BEIS, it kind of gave it a higher profile internally when asking for money. I think once we started the train rolling and made the application, it really helped build the internal momentum more than if it was just an internal saving idea. So I think that was good.
And you said as well that you were surprised that such a big project was funded through the Ietf.
Yeah, we were. Yeah, we weren't sure whether we were asking for too big a piece of the pie. So. Yeah.
No, we like big projects as well as small projects. That's great. Thanks, Tim. And John?
Yeah, thanks, Jenny. I think I'd say a couple of things. 2050 feels like quite a long way away, but it isn't really that far away. But we are making big capital investments in this area to get down to net zero 2050. And I don't think anybody wants to invent or invest in old hat technology.
Yeah.
So part of the benefit of this is that we can try to invest in technology that's going to be viable for the next 30 years. There's the old adage about no good reinventing a candle when someone invents a light bulb. So we're hoping that some light bulbs have been invented in UK PLC, and we can invest in those and get them up and running at our site.
Lovely. And Alex, do you think it's helped the Ietf is a capital investment fund rather than R&D?
Well, I think for us, I think it acted as a catalyst to kind of bring this project forward, because it represented well a more than 50% of the cost of the project, and almost like John was saying, I think we're seeing all 2050 as already impacting on some of our investment decisions, because our kilns and major capital investments are on 25-year cycles, and we're butting up to 2050 already with those decisions, and unless we can crack this carbon nut, we are really seeing this is an existential threat to our business. So it's it's very welcome, and it's part of the sort of, I think, the joined up thinking that we need between government and private business.
That's excellent to hear. And is there anything that you would do differently? Is there any feedback that you can give to BEIS for improving on future rounds from any of you, if anybody has any comment?
I think the comment from our side is we have quite specific time windows. Our capital program, we're planning over a 4, 5, 6 year timeline, because we only shut the refinery down once in 6 years.
Yeah.
And so it can be a little bit tricky to time, the application and the funding, and then it's got to be completed. But that's got to tie it with the turnaround. So actually, this particular project is interesting because it breaks that cycle a bit, because we build the furnace offline. The counterfactual, we have to do it in that shutdown window, whereas this we build offline and then we can tie it in. And so more flexibility there would help us, because we're just very constrained on that. So for this current window that's opened, we're a little bit limited by what can we deliver in that grant time frame.
And John, is there anything that you would how you would improve on it?
I think it's very good, Jenny, and I think Innovate UK and BEIS and yourselves have been listening to what our feedback has been, I think, from everybody, and I applaud you for that. just one thing I think everyone has to be aware of is you know, submitting these application forms whilst also running the business, and especially during the COVID-19 period that we've been through, it's not easy. So I just recommend to everyone to give yourselves time. And I think a few other speakers alluded to this as well, that if you give yourselves time and get yourself prepared and find out all the details that you need for the application form, actually, to be honest, the application form is pretty straightforward if you give yourself time. It's only if you're burning the midnight oil at midnight the night before that it becomes a bit hairy. So don't do that.
Completely agree, John. Completely agree. This is not a 1 hour over lunch
No.
job.
No.
This is something you need to put a bit of time into. So that's
and be fair to the people that can help as well. If you ask a question a month in advance, that gives everyone a chance to answer the question, and it prepares. Just like the other speaker said, it also prepare internally and externally for what you're about to get into, because it is a big deal, but they're big projects, so take them very seriously. They are very important.
And Sebastian?
Yes, Jenny, I think I would like Tim's comments about the timings and, you know, the cycles. And I guess I know it's sometimes difficult to plan, but having visibility of what's coming in, let's say, phase 2. For example, you've got it at the moment, it will be open, but we don't know when it will be open and for how long and what will be in scope. You know, I've got a project at the moment that we are racing against the time to meet 14th of July, for example. Mm-hmm. But maybe we could comfortably say, well, it will fit in phase 2. Mm-hmm. So I'm not sure how many more people will be in the same situation.
Yeah. Okay. Thank you. And lastly, Alex.
Well, I think much like some of the points made just now, you know, it's not a overall difficult process to fill in the application, but you know, we don't have a resource within a business of our scale to do these sort of things, and you know, we're running a business, and you know, got all the day-to-day activities that need to sit alongside that. So it's you know, I think to make it the simpler these things can be made, the better. And also, you know, the monitoring side of things, when once you've got the grant approval to actually get the funding starting. So there's quite a period between there where we had to demonstrate an awful lot of bits and pieces, which I felt maybe could have been done within the grant application itself, so that once it's granted, you're going ahead with it. And then just also some greater linkage, I guess, from a feasibility study to the deployment, because what would be difficult for us is you know, once we've determined the viability of the project, to find that we then don't secure the funding through a second round deployment application, and because then, you know, ultimately the work done on the feasibility study will it just doesn't have the natural flow on.
Okay, so you prefer a sort of two-stage process, so you're applying for both at the same time?
Possibly with you know, certain things that you might need to have achieved at the end of your feasibility study to, you know, get you through to the next stage, but to have that somewhat predetermined, so that you got a very clear goal and an objective to get to the next bit, which is where, in our case, the value is going to be delivered. I think the feasibility study, you know, it's not saving a gram of CO2 at this stage.
Yeah. Okay, lovely. Now we've got some questions that come in from the audience. So first for Tim, Steve Wellburn said, have you considered heat or heat storage to match your steam supply with steam demand? Is that something that you've considered?
Yes, we not very deeply, to be honest. I mean, we have quite a variable steam demand, and at the moment, where we are today, we've got quite a lot of flexibility in our steam supply, and so it's not really a problem. That situation does evolve, you know, when you look out into our roadmap. I mean, our direction of travel is less steam demand, more electricity, and we need a certain amount of steam generation capacity available for certain big trip situations, but we don't actually want the steam normally. So yeah, in the kind of sort of 5-year time frame, that becomes more of an issue. Yeah, there's kind of two ways to attack it. You know, what's driving the variability, and perhaps we can reduce that, and then perhaps storage. And then the other thing that's also more interesting and becoming more interesting is the variability of renewables and power price. So we can choose to buy power or make power, and our power and steam are very much linked. So for a site like us, storing steam is a kind of alternative way to, instead of a battery, to balance stuff up. So there's definitely value there, but we haven't really looked at it. It's more medium term thing.
Okay, thank you very much. So thank you all very much to all of my 4 projects speakers. It was really useful, and I'm hopeful that has been useful to the audience as well in giving them some ideas for their projects. We do have a few more questions that have come through more generally around the scope. So these are more for Julia and BEIS. So starting from the first one we had from Chris Pete, he's asked, if we had an industrial pump or fan that would deliver an energy reduction through installation of a variable speed drive to control the motor, what costs would be eligible for the grant? So Julia, would you like to take that one?
Yes, of course. Now, I popped a little bit of a reply. We'd like to look and understand the project in a little bit more detail, but where you can demonstrate that the investment is solely aimed at improving the energy efficiency, then in some cases we can look to fund the total project costs. But we would just need to understand a little bit more about the details. So please drop a note to the Ietf mailbox, and then we'll be able to give you more advice.
Lovely, thank you. And another one for you, Julia, from Mark Dickinson. Would replacing old 11 kilowatt transformers with high efficiency losses be 100% or part funded?
Again, probably need to know a bit more about the project, but as a general rule in that particular instance, then that would be almost like a part-funded project. So a counterfactual would need to be stated, which would be a less energy efficient transformer of a similar less energy efficient transformer, and then the eligible cost would be the difference between those two. But again, for to be sure, please drop a note to the Ietf mailbox.
That's great. Yeah, this is much easier to give advice when you've got a full picture, isn't it? So please do. And then Mark Bonner, we're a zero carbon manufacturer of sustainable 3D printed luminaires with connected LEDs. Would partners that can install these be eligible for this funding?
So unfortunately, in that instance, that is not eligible for Ietf funding because it's not directly related to an industrial process. And in the guidance, we do state about system upgrades, such as building lighting, unfortunately not being in scope. So no, I'm afraid.
Okay, thank you very much. I'm afraid we've reached the end of the Q&A part for today, but if you did ask a question and it wasn't answered, then please do get in touch and we will do our best to answer that later on today or later in the week. So thank you to all of my speakers. I'm now going to take you through the last presentation of today, and this is about the support that's available to you from myself and from Innovate UK to help you with your applications. So next slide, please. So I'm going to cover how the help that's available to help you find partners if you want to partner with someone, and to give you a better understanding of the eligible or relevant technologies for the Ietf programme. I'm going to talk about the help to find and understand the competition information. I mean, obviously we've been presented today and seen the scope and eligibility, but there's a lot more information available. And then also how we can help you with the application process itself. So next slide. So in terms of finding partners or technologies that you could install on your site, the first port of call is the one we've been talking about a lot today already. We have a dedicated Ietf networking platform called Meeting Mojo And that's been set up, it's been open since the competition's opened at the beginning of March. So there's over 150 people on there at the moment, probably gone up today with people booking one-to-ones. But you're confident that everybody on there is interested in the Ietf. That's why they're on there. So once you've registered and have access to the site, you can direct message people on there and organise meetings to be able to discuss possible projects that you could do together, or just to share a bit of information about yourselves. So that would be the first place I would say to go to start looking for partners. If you don't have any luck on the networking platform, then you can come and email myself. So if you just wanted to talk about your project ideas, or if you were looking for a particular technology and didn't know companies that could help you to install those technologies, then please drop me a note on my email and I will do my best to match you up with somebody. Another thing that's new for this spring window that we're intending to continue, because it's been very popular, is our virtual technology marketplace. So this is an online platform that's just available to manufacturers and data center owners who register to have access to it. On the platform, technology providers have recorded 5-minute videos about their technology and what it could potentially do for you in terms of reducing your energy demand or reducing your carbon emissions. All of the videos have been vetted, so we know that the technologies are eligible for the Ietf. So if you're a manufacturer or a data center owner thinking of applying to the Ietf and you just want to have a look and see what's on offer, that you could pick companies that you could work with, then please register at that link and you will be given login details to be able to go and view at your leisure the videos that are on there. And that will remain open until the competitions close on the 14th of July. Next slide. In terms of the information, there is so much information. Obviously, we've heard a lot today, but I've provided the links to, on the government web pages, the links to both of the competitions. So this is where you go when you want to actually start your application. It talks you through what's in scope, who's eligible, what the rules are and how to apply. And then there's the button that you press to actually start your online application. So those two guidances and applications are there. And also there's supplementary guidance on the government website at the third link there. And that's for things like the GIS map that will show you if you're in an assisted area or not. And that will determine how much grant you get for deployment, that type of thing. Again, if you would like to run your ideas past either myself or Innovate UK, then we have the eligibility checkers. So I would start with Innovate UK. They have a dedicated Iutf email that's there on the screen now. And they will come back to you, give them a nice detailed description of your project idea, and then they can have discussion with you and let you know if they think that's eligible or not. And you can also talk to me as well. As I said, we are recording today's event, but we also recorded the one in March, and the extra presentations that happened in March were, we went into a lot more detail about the eligibility rules, and also there was a kind of step-by-step process of how to apply with screenshots of the online systems. So if you want to watch that again, then the link to that recording is there. And finally, I've provided a link to the list of all of the funded projects that Julia mentioned this morning that were funded in phase 1. This is the sort of first tranche of phase 1 funded projects that has come out. So you can go and have a look on BEIS website, and it gives a little bit more detail about what those projects are doing. Next slide. So in terms of help with the application process, the KTN has been funded by Innovate UK and BEIS to offer a free service to provide constructive comments on your application prior to submission. So we can't write the application for you, and I can't guarantee that you'll win, but we can provide, as I say, some tips and comments on how to strengthen your answers that you've given for the questions on the application form to give you the best possible chance of success and get those scores up. We also have competition clinics. These are fortnightly clinics that have been running since the beginning of March. There are 2 more left to go in June on the 15th and the 29th. These are open forum webinars, so it's not a confidential one-to-one thing, it's a group thing where you can put questions to BEIS, Innovate UK or myself about any questions you might have about scope or eligibility or the application process. So if you'd like to come to either of those last 2 clinics, if you think of a question after you leave here today, then please do register for those clinics at the link there. Next slide. And the last thing I want to mention is the KTN's Innovation Exchange. So as I mentioned this morning in my presentation, the Ietf doesn't fund you to find all the different technologies that might solve your problem, solve your challenge of reducing your energy demand or decarbonising. You have to have already chosen the technology you want to deploy. The Innovation Exchange allows you to define a challenge, to post it on our portal, and then we run a competitive process where we'll promote it to lots of energy tech companies that might be able to solve that challenge, and then they pitch to you their ideas. And that might help you to find some technologies that maybe you haven't seen before, and then that could hopefully lead to future Ietf applications. So if that is something you'd be interested in, it's free for energy related challenges. So the link to the website so that you can have a little bit more of a look at it is there, but please do get in touch with me as well if that could be useful to you. And I think that's probably it from me. Yeah, so no more questions. We've done the questions bit, but I would now like to hand over to Catherine Barber for our closing remarks.
Thank you very much, Jenny, and to you and Julia and all of our speakers this morning. Lots of excellent advice there about how to apply and how to get help as you're preparing your application. Jenny, I think you were too modest to say so, but in the first window, people who came to you and to Innovate UK for advice definitely had a better chance of succeeding when they put in their application. The sort of pass rate was higher. And that's not because we're biased or that there's a tick box saying that you've approved it, but just that you give really good advice, and you can make sure people understand all the rules and what we're looking for. And thank you as well to the companies, our 4 speakers who talked about their projects. Those case studies are hot off the press. We've only just announced the names of the first phase 1 winners. So it's just really nice for us to be able to talk about what we're funding and to see those examples. I hope they were useful for you as well if you're considering putting in an application. So just a final endorsement from me, do use the eligibility screening service, the application support service. Do try and get your application submitted before the very last minute. It will be better for your blood pressure and for ours, and avoid any technological risks at the end with websites crashing. Sure, that wouldn't happen, but you know, try and save yourself at least a day or 2 in advance. And lastly, we still have some availability this afternoon for the one-to-one sessions, so feel free to book in with me or colleagues in BEIS. Thank you so much.
Thank you, Catherine. Thank you. So I'd like to say again, thank you to all of you for joining us today. We hope that it's been useful. I wish you the best of luck with your applications, and that's it from us. Thank you.